Hello everyone. Today we are going to solve the 7 mark sums in De Moivre's theorem unit number 2. Right? So what is the sum we have to solve it now? So it's if n is an integer, show that I plus 1 power 2n plus I minus 1 power 2n equals 2 power 1 n plus 1 cos n pi by 2. Right? Right. Shall we start this? Yes. Solution. So to solve this I am going to take this part alone and we are going to do step by step. So I am going to take I plus 1 plus I, right. So what I want is 1 plus I power 2n. So initially I take 1 plus I. So I am going to multiply this term by root 2 and divide the same term by root 2. So I am going to take 1 plus I multiplied by root 2 and divided by root 2. Right. So the value remains same. Right. So I am going to multiply and divide this term by root 2. Right. So I am rearranging this term now. So I am going to write this root 2 in the numerator here and I am going to take this root 2 in the denominator, right, inside this bracket. So it will becomes 1 multiplied by 1 by root 2 will be 1 by root 2 plus I multiplied by 1 by root 2. Right. So now what is the result? So it is in cos n pi by 2. So now we have to think in which cos term we will get the answer as 1 by root 2. So we know that cos pi by 4 which is equals 1 by root 2. Similarly sin pi by 4 which is equals 1 by root 2. Clear. We are going to substitute this one here, right. So I plus 1 which is equals root 2. In this place 1 by root 2 we are going to write cos pi by 4 plus in imaginary part 1 by root 2 we are going to take sin pi by 4. Right. Now only it looks like cos theta plus I sin theta, so that we can substitute De Moivre's theorem, right. For that we multiplied root 2 by root 2 and we take the root 2 outside, and for 1 by root 2 we substitute cos pi by 4 and in the imaginary part we substitute sin pi by 4. Clear. Now we are clear with the value of 1 plus I, right. So what we want is 1 plus I power 2n, right. Before this I am going to name it as equation number 1, right. So from this we can easily write 1 minus I, which is nothing but we are changing the sign of imaginary term, so it will also becomes root 2 cos pi by 4. It's a real term, so it doesn't change. For here it's a I, we changed the sign of a imaginary part, here also the sign will change, so it will becomes minus I sin pi by 4. It is 2. So we now know the value of 1 plus I and 1 minus I. What we want is 1 plus I power 2n, 1 minus I power 2n. So we are going to raise their powers. Shall we do that? Yes. So I am going to take 1 plus I which is equals root 2 cos pi by 4 plus I sin pi by 4. This is what we find. So what we want is 1 plus I power 2n. Clear. So I am going to raise the power of the entire term to 2n. So I sin pi by 4, the entire term powers 2m. right? Here you have to know little bit, get into this, right? You have to take root 2 as a single term and this entire term as a single term, because in between this we have to multiply, not add or subtract. So we can take the power separately. So root 2 power 2n and cos pi by 4 plus I sin pi by 4 power 2n, right? So what we can rewrite this term. So root 2 square the whole power n. I am just separating this 2n, so it will becomes root 2 power 2 the whole power n, right? I am going to take this cos pi by 4 plus I sin pi by 4 power 2n, right? Okay, root 2 the whole square will be root 2 the whole square, which is equals root 2 into root 2. So it will becomes root of 2 into 2, it will equals 2. Clear. So root 2 square will be 2 power n, right? So here cos pi by 4 plus I sin pi by 4 power 2n. So what is De Moivre theorem? Cos theta plus I sin theta power n equals cos n theta plus I sin n theta. Just what we do here is, whatever the power may be, we are going to multiply the power with the angle, right? So we are going to apply this here. Root 2 remains, 2 power n remains the same. Here what we have, cos pi by 4 plus I sin pi by 4 power 2n. So we are going to take this 2n within this angle. So it will become cos 2n multiplied by pi by 4 plus I sin 2n multiplied by pi by 4. So here 2n and pi by 4 are in multiplication. So we can do this like this. So we can separate the angle with this plus sign, right? I am going to cancel this. 1 2s are 2, 2 2s are 4. Likewise 1 2s are 2, 2 2s are 4. So we can write 2 power n cos, what we have, n pi by 2 plus I sin, what we have, n pi by 2. Clear. This is the value of 1 plus I power 2n, right? So we find the value of 1 plus I power 2n. So I am going to name it as 3. So now we similarly solve this for 1 minus I power 2n. So then we put it in, add those things, and we find whether it equals to 2 power n plus 1 cos n pi by 2 or not. Shall we solve this? Yes. So from equation 2, what we know, 1 minus I equals root 2 cos pi by 4 minus I sin pi by 4. What we have to find is 1 minus I power 2n, which is equals root, we have to find, right, 1 minus I power 2n. So I am raising, what we done here, we raised 1 minus I to the power of 2n. So I am doing this to the right side also. So it will becomes root 2 cos pi by 4 minus I sin pi by 4 the whole power 2n, right? So this term and this entire term are in multiplication. So I am going to make this 2n for them separately. So it will becomes root 2 power 2n, it will becomes cos pi by 4 minus I sin pi by 4 power 2n. So I am rewriting this as root 2 the whole square power n. As we already know, root 2 squared is equals to, right? Right. I keep this term as it is. So we know root 2 square equals 2. So 2 power n will be 2n. So it will remains cos pi by 4 minus I sin pi by 4 power 2n. Right? Right. So now we are going to apply de Moivre's theorem. What is de Moivre's theorem? Cos theta plus I sin theta the whole power n equals cos n theta plus I sin n theta. So whatever a power may be, we are going to multiply the power to the angles of the theta, right? Right. So what we have here, 2n. So 2 power n, here it is 2 power n. We are going to substitute the de Moivre's theorem here. So cos, what is the power? 2n multiplied by, what is the angle here? Pi by 4 minus I sin, what is the power here? 2n multiplied by, what is the angle here? Pi by 4, right? Right. So we are going to simplify this. 1 2s are 2, 2 2s are 4. So it will be 2n cos n multiplied by pi. So it will be n pi divided by 2 minus I sin, likewise here 2 we are going to simplify. 1 2s are 2, 2 2s are 4. So n multiplied by pi equals n pi, what we have in the denominator? 2, right? This is the value of 1 minus I power 2n. I am going to name it as 4. From equation 3 and 4 we know the value of 1 plus I power 2n and 1 minus I power 2n. Now we are going to add both the things. So now we know the value of 1 plus I power 2n and 1 minus I power 2n. I am going to add those two things. So it will becomes 1 plus I power 2n and 1 minus I power 2n. So what is the value of add? I am going to add those things, two things. What is the value of 1 plus I power 2n? It is here 2n multiplied by cos n pi by 2 plus I sin n pi by 2 minus, what is the value of 1 minus I power 2n? 2n cos n pi by 2 minus I sin n pi by 2. Clear? Clear. In both the terms what we have in common? 2 power n. So I am taking this out, 2 power n. So what we have here? Cos n pi by 2 plus I. So we are adding these two terms. For 1 plus I we substituted here addition, so it will becomes addition. So 1 minus I power 2n will be this term. I am taking 2 power n in both the terms as common. So when we take this term out here, it will remain cos n pi by 2 and sin n pi by 2. What in between these two? We are adding this. It is a plus sign. So this side also remains same. So plus cos n pi by 2 minus I sin n pi by 2. Okay. So 2 power n in common. What we have here? 1 cos n by 2, here n cos n by 2. So it will becomes 2 cos n pi by 2, right? Right. Likewise, here we have I sin n pi by 2 minus I sin n pi by 2. So it will become 0, right? So okay. So it will becomes 2 power n multiplied by 2 multiplied by cos n pi by 2. Here see, it is 2 power n, it is 2. So we can rewrite 2 as 2 power 1. Now we can see that these are power numbers with same base. If the base is same, we can add their powers. So it will becomes 2 power n plus 1 cos n pi by 2. Now look at the question, what we have to solve? We have to solve is 1 plus I power 2n plus 1 minus I power 2n equals 2n plus 1 cos n pi by 2. We proved it, right? Right. So we have to prove 1 plus I power 2n plus 1 minus I power 2n equals 2 power n plus 1 cos n pi by 2. So we proved it. So we can write hence proved. Shall we do a short recap? Yes. So initially we find the value of 1 plus I and 1 minus I, and we find the value for 1 plus I power 2n and 1 minus I power 2n. Then we add both terms, the sign values get cancelled, and the final result is equal to what we have to prove, right? So we proved this sum. So we are going to solve a similar sum like this. So you can also remember this method clearly. Thank you. Shall we move to the next sum? Yes. So what is the second sum we are going to do? In the second sum is, if n is an integer, then show that 1 plus I power n. What we have in a previous sum? 1 plus I power 2n. So here we have 1 plus I power n plus 1 minus I power n, which is equals 2 power n plus 2 divided by 2 cos n pi by 4, right? Right. So shall we start to solve? Yes. So you guys going to solve this along with me because it is much more similar to the previous sum, right? Right. Solution. Right. What now we are going to start with? Yes, 1 plus I, right? I am going to multiply and divide this by root 2 int 1 plus I. I am going to replace this 1 plus root 2 by root 2 as like this. I am just separating the numerator and the denominator. So it will be root 2 multiplied by 1 by root 2. So what is here? 1 plus I. I am going to take this 1 plus 1 by root 2 within this. So root 2, 1 multiplied by 1 by root 2 will be 1 by root 2 plus I multiplied by 1 by root 2, 1 by root 2 I. Clear? Clear. So we are going to use de Moivre's theorem. So that what is de Moivre's theorem? So cos theta plus I sin theta power n equals cos n theta plus I sin n theta. So we have to make this term in form of cos theta plus I sin theta. So that I am going to replace cos 1 by root 2 in replace 1 by root 2 in cos theta format. So which cos will be equals to 1 by root 2? It is cos pi by 4. Clear? Cos pi by 4 equals 1 by root 2. Similarly, sin pi by 4 also equals 1 by root 2. Right? If now I substitute this cos pi by 4 here and sin pi by 4 here, the entire terms will change in form of cos theta plus I sin theta. Shall we do that? Yes. So I am keeping root 2 as it is. So for this 1 by root 2 I am substituting cos pi by 4 plus I here to I. For this imaginary part 1 by root 2 I substitute sin pi by 4. Super. This is 1 plus I. Okay. Do we have any other terms in a question? Yes, we have 1 minus I. Okay. What is the difference between these both terms? Here imaginary term is in positive. Here imaginary term is in negative. So if we change this term's imaginary part sign, we will get 1 minus I. So 1 minus I, which is equals root 2 multiplied by cos pi by 4. These are real term. Minus, here only I, so this part is only imaginary term. Minus I sin pi by 4. Clear? Now we find the value of I plus 1 plus I and 1 minus I. Right? Clear? Clear. Now we are going to find the value for 1 plus I power n. Right? Right. Shall we go? Yes. So we found 1 plus I equals root 2 cos pi by 4 plus I sin pi by 4. What we have in a question is 1 plus I power n. This term is raised to the power of n. So to the right hand side will rise to the power of n. So root 2 multiplied by cos pi by 4 plus I sin pi by 4 power n. So these two terms are in multiplication. So this we can do the powers separately. So it will be as root 2 power n, and here it is cos pi by 4 plus I sin pi by 4 power n. We can write root 2 as 2 power 1 by 2. Clear? Clear. So it will be 2 power 1 by 2 multiplied by n. Right? Right. So it will become root 2 will be 2 power 1 by 2. Here it is a power n. Right. So this term will remain same. Cos pi by 4 plus I sin pi by 4 power n. Right. So 2 power, these two are in multiplication. So, like, see here 1 by 2 power n. So it will becomes 2 power n by 2 cos pi by 4 plus I sin pi by 4. So power n. Now we are going to apply De Moivre's theorem. What is De Moivre's theorem? Cos theta plus I sin theta. Here cos pi by 4 plus I sin pi by 4 power n equals cos n theta plus I sin n theta. So if cos theta plus I sin theta have some power n, means we are going to take this n with their angles, right? So their angles will be multiplied by their power. So what we have in power n, what we have in angle theta. So it will becomes cos n theta plus I sin n theta, right? Right. Likewise we are substituting this here. So 2 power n by 2 cos pi by 4 plus I sin pi by 4 power n. So this n will get into this. Likewise in a formula. So what we have, cos n pi by 4 plus I sin n pi by 4. Clear? This is the value of I plus 1 power n. Right? I am going to name it as 1. So now we find the value of 1 plus I the whole power n, which is 2 power n by 2 cos n pi by 4 plus I sin n pi by 4. Now we are going to find the value of 1 minus I power n. Shall we do that? Yes. As we already know, the value of 1 minus I equals root 2 multiplied by cos pi by 4 minus I sin pi by 4. So what we have to find is I minus 1 minus I power n, right? We have to find 1 minus I power n. So what will be the right hand? It will becomes root 2 cos pi by 4 minus I sin pi by 4 power n. Right? I am going to take this power n within this. So it will becomes root 2 power n cos pi by 4 minus I sin pi by 4 power n. We can write root 2 as root 2 power 1 by 2. Here what we have power n. Right? So it will be like this. I am keeping this cos pi by 4 minus I sin pi by 4 power n as it is. So here it will becomes 2 power n by 2. Right? I am just multiplying 1 by 2 and n. Right. So here it is cos pi by 4 minus I sin pi by 4 power n. Now we are going to apply De Moivre's theorem. What is De Moivre's theorem? Cos theta plus I sin theta power n equals cos n theta plus I sin n theta. Similarly, cos theta minus I sin n theta, sin theta power n equals cos n theta minus I sin n theta. So in which format we have? In this format, cos theta minus I sin n theta, likewise here. So what we have? Cos pi by 4 minus I sin pi by 4. This is in the form of cos theta minus I sin theta. So we are going to apply this formula here. So it will becomes, so 2 power n by 2 will be similar. So cos pi by 4 becomes cos, what is the power here? N. So it will become n pi by 4 minus I sin, what is the power here? N pi by 4. So now we find the value of 1 minus I power n, which is equation number 2. So already what we have a equation 1. What is that? We have a equation 1, that is a value for 1 plus I power n. So now we find the equation for 1 minus I power n. If we add both the things, we will get 1 plus I power n plus 1 minus I power n. Okay. Shall we add equation 1 and 2? Yes. Now we are going to add equation 1 and equation 2. So 1 plus I plus 1 minus I power n, which is equals, what is 1 plus I power n, which is 2 power n by 2 multiplied by cos n pi by 4 plus I sin n pi by 4. What we have here? Addition. So plus, what we have next? 1 minus I power n. What is the value of 1 minus I power n? 2 n power 2 n by 2 cos n pi by 4 minus I sin n pi by 4. In both the terms, what we have common? 2 power n pi by 2 power n by 2. Here also 2 power n by 2, here also 2 power n by 2. So I am going to take that in common. So 2 power n by 2. So what remains? So cos n pi by 4 plus I sin n pi by 4. What we have here? Plus cos n pi by 4 minus sin n pi by 4. Okay. So 2 power n by 2 cos n pi by 4 plus cos n pi by 4 becomes 2 cos n pi by 4. I sin n pi by 4 minus I sin n pi by 4 becomes 0, right? So it will be equal to 2n pi by 2 multiplied by 2 multiplied by cos n pi by 4. We can write 2 power 2 as 2 power 1. So 2 power n by 2, 2 power 1 cos n pi by 4. So we have two terms with different powers. So 2 power n by 2, 2 power 1. Here both their bases are same. So we are going to add the power. So 2 power of n by 2 plus 1 cos n pi by 4. So we are going to cross multiply this. So it will becomes n, 1 2s are 2, so plus 2 divided by 2. So this is the power of 2, right? Right. So here cos n pi by 4, right? Right. So what we have? 2 power n plus 2 by 2 cos n pi by 4. So this is the value of 1 plus I power n plus 1 minus I power n. What is in the question? In the question we have to prove 1 plus I power n plus 1 minus I power n equals 2 power n plus 2 by 2 multiplied by cos n pi by 4. So here also we will get the same answer. So we proved this sum, right? So hence proved. That's it, guys. I hope you all clear with this sum. We will meet in the next sum. Thank you.